So the lesson today is on limits that involve infinity. And the other day when we were talking about limits that don't exist, um, the question was brought up about what if the limit doesn't exist, but we know that it's going up or down towards infinity or negative infinity forever. And so we could talk about the fact that that limit doesn't exist, but describe what's happening. And that's really what this lesson is about. So we're going to talk about one-sided limits that go to infinity or negative infinity. And it says, by definition, the line x equals 1 is called a vertical asymptote of the curve y equals f of x if at least one of the following statements is true. And we talked about this in pre-cal. So let's look at it as a limit, though. So here's our line, our asymptote, and we're saying as x approaches a coming from the left-hand side, then our value goes towards infinity. Now, it doesn't say where we are, so it really doesn't matter where you start this. I'm just going to start down here. But it's saying that as I come in from the left, I go up towards infinity. So this would look like this picture. All right, so let's look at this next one over here. The limit as x approaches a, this time coming from the right-hand side, goes towards infinity. So again, I don't really know where this graph starts. I'll start it somewhere else just so you know that I'm not really, not really sure where it starts. I'm just saying that wherever it is, as it comes in towards that asymptote, it's going up towards infinity. So this next picture then says the limit as x approaches a, doesn't say from the left or the right, which means the overall limit is approaching infinity. So that means coming from both directions, this graph is approaching infinity. All right, then we move to negative infinity. So this one's saying as x approaches a coming in from the left, we're going towards negative infinity. And then this one says that as x approaches a coming from the right, we're going towards negative infinity. And this last one says the overall limit as x approaches a is negative infinity. So coming from both sides. So we can talk about what is happening at that asymptote as infinity or negative infinity, even though in all of these instances the limit doesn't exist. We're just talking about what is happening on the graph. So let's look at this example down here of a function that we might want to sketch or at least go through the factoring so we'll know what's going on our graph. So if I factor out an x, I'm going to have x minus 3, x times x minus 3 over x minus 1. So I know that this graph is going to have a vertical asymptote, like all these pictures up here. It's going to have a vertical asymptote at x equals 1. So I do kind of need to know what's going on this graph. This one ends up having a slant asymptote because it's squared on the top and not on the bottom. But if I put in a value coming from the left, or actually let's go ahead and take a look at this graph so we'll know for sure what it looks like. So let me put it in real quick. Alright, so I've got it typed in here. The glare is so bad. Maybe I can try flipping off this light. Didn't go off. Doesn't want to go off. Alright. So anyway, here's my function. Just typed in that function. Here's my graph. So as I come in towards that asymptote, on the right hand side it's going up, on the left hand side it's coming down. So that's what these limits are asking me. The limit as x approaches 1 coming from the left. On the left hand side, this thing is going towards positive infinity. Then it asks me coming from the right. Coming from the right, going towards negative infinity. The overall limit as x approaches 1, even though we can describe what's happening on the graph, it asks for the overall limit and they are not going in the same direction. I can't describe that, so I'm going to have to say that it does not exist. Even though these also don't exist, I can at least describe what's happening. Right, so the front side was talking about vertical asymptotes, and so we were saying x was approaching some value and y was approaching infinity or negative infinity, which is the definition of a vertical asymptote. On this side, we're talking about x is approaching infinity. We're asking what's happening to y. This would be a horizontal asymptote by definition. So we did this last year without limits. We just talked about what is kind of happening. So I'm going to do this first one as a limit, and then we're gonna talk about our shortcuts that we came up with last year. But here it says change the form by dividing by the highest exponential power. The highest exponential power here is x squared. So we have 3x squared over x squared minus 2x over x squared minus 3 over x squared all over 2x squared over x squared plus x over x squared minus 2 over x squared. And we did this last year. So we know that some of these reduce down. So we're going to get the limit as x approaches 0 of 3 minus 2 over x minus 3 over x squared over 2 minus 1 over x minus 2 over x squared. And now we're supposed to be plugging in this limit as x approaches 0. Well, like we talked about last year, we just didn't really have a good concept of limits. If I get x very close to 0 here, I just realized I was saying as x approaches 0, and this is supposed to be infinity, so let's change these to infinity. So the limit as x approaches infinity is if I were to put a very large number in here for x, as x gets very, very large, this number would be approaching 0. The bigger I put in, the smaller this fraction, the closer it gets to 0. So all of these are just going to approach 0, and I'll just end up with 3 over 2. Now, I'm not going to go through this process on every single one of these, but you guys might remember that since these are all horizontal asymptote rules, as x is approaching infinity, then what we discovered was that if those are the same, then the horizontal asymptote is going to be from the coefficient in front. So the horizontal asymptote here is y equals 3/2. Whenever the exponent in the numerator was smaller than the one in the denominator, our horizontal asymptote was y equals 0. And in the last one, when the exponent in the numerator was greater, our horizontal asymptote did not exist. We don't have one. Now, we can go through that process of dividing out. What happens on this one is you end up with 3 divided by 0, because all of these are going to 0 out, and you can't divide by 0, and that's why it doesn't exist. In this instance, you would have 0 divided by 2, and 0 divided by 2 is 0. So For the most part, when you see limits as x approaches infinity, you can really just use your horizontal asymptote rules. Much, much shorter.